Thank you, Kelsey. So my name is Alex. I'm a software developer on the operating systems team at CoreOS, and I'm here to talk to you today about Ignition. So what is Ignition? Well, it sounds pretty cool, right? Well, Ignition is a new utility we're working on that's going to be responsible for configuring your machines on boot. This entails things like writing files to the file system, writing systemd units, writing network config. Now, some of you are probably hearing this and thinking to yourself, wait a minute, this sounds an awful lot like CloudinIt. What about CloudinIt? I know Kelsey just had you raise your hands, but I wasn't paying attention. How many of you use CloudinIt today? All right, good, just about everyone. That's what I'd expect. For those of you not familiar with CloudinIt, CloudinIt is the utility we use on CoreOS to configure the machine on every boot. Again, it's responsible for creating users, writing files to the file system, starting services, etc. Now, how is Ignition different from CloudinIt, right? The two descriptions sounded quite similar. Well, in many ways, it is actually the same. Both utilities serve to solve the same problem, and that is configuring a machine on boot. You need to do some configuration to your machine to give it identity in your network before it can come up and start accepting work. Over the past year of using CloudinIt, we found that there are a number of hurdles, and I want to walk through some of these hurdles before talking about how we solve these with Ignition. So let's take a look at a fairly basic cloud config. Many of you have seen this. Quite a few of you have probably actually used this in production. But I want to call out specifically in this example the public IPv4 and private IPv4. These are a mechanism of cloud config called variable expansion. And this is how we get dynamic data into the cloud config today. So in this particular example, we'll be telling etcd to come up using both the public IPv4 address and the private IPv4 address for security reasons. The problem with this approach, though, is that CoreOS CloudinIt only really supports public and private IPv4 and IPv6. What happens if you're running in an environment where you have a third Ethernet device or a VPN, or you want to know information like what region is my instance running in? We don't really have an answer for that today. As a result, many people have started using what I refer to as the two-stage cloud config. The piece I want to point out with this specifically is the fact that we're escaping this variable. The // actually escapes this, so CloudinIt won't actually perform the variable substitution. We're actually looking at the second stage of the two-stage cloud config. If we look at the first, we see that it's a bash script. We're back to using bash scripts for initialization. This is horrible. Lord have mercy. So let me walk through this real quick and explain what this is doing. So the first piece of this is an example function that we use to get the IPv4 address of an interface. We then use that function to get the public and private IPv4 addresses. In this case, it's eth0 and eth1. We write the cloud config that we just looked at onto a temporary location on disk, and then we actually tell CoreOS CloudinIt to use that file to execute. This is the best strategy for working around using custom data at this point. It's not great. The next hurdle I want to talk about is networking. So I'm curious, how many of you have tried to get statically configured networking working via CloudinIt? And how many have actually succeeded in doing so? Oof, even less. OK. So why is networking so tricky to set up with CloudinIt? Well, in order to understand this, I'm going to walk you through a few example boots. And I'm going to visualize these with this high-tech boot timeline. On the leftmost edge of the graph, we have the moment that the machine powers up. Moving toward the right is the future. So of course, the first event in the timeline is the moment that the machine is powered on. This may be a physical server where somebody walks up and pushes the power button, or this may be an AWS or some other cloud provider where the virtual machine is spawned into existence. The next interesting moment on the timeline is what we'll call the user space boot. This is really the moment that the user space systemd takes over and begins executing service units and generally booting user space. Some point later, our network will come online. And after that, we'll run CoreOS CloudinIt. Theoretically, at this point, CloudinIt will start all the services we need. System is up and running. It's accepting work. The user's happy. Except that in this scenario, because we're running CloudinIt after the network is online, it's too late to configure it. Well, that's not ideal. So what about if we take CloudinIt and we instead run it before the networking? Now we have the ability to write down any network units we need, and we can kick it over to networkd to set this up, right? This sounds pretty good. The problem with this approach, though, is that now we don't have the ability for CloudinIt to start services which depend on the network in order to start, which is even worse for the user. Now, why is it? Why is it that if we run CloudinIt before networking, why is it that we can't depend on the networking in any services that need to start? This brings us to the next hurdle with CloudinIt. When CloudinIt starts services for you, it actually starts them in a serial fashion. So we have systemd on our system, which is the main init system, and then we've got CloudinIt, which is this little sidekick init system, which also will fire off services. And the way that it does this, it will go step by step through all of the services that need to be started, and it will have to successfully start this step 1.service before it can move on to step 2. Similarly, it must finish starting step 2 before it can move to step 3, so on and so on for all of your services. Now, what this means is if you have a particular service which depends on networking in order to start, and the networking isn't available, it will actually hang the rest of the services waiting for this one to start. So if we go back to our timeline here, we see that CoreOS CloudinIt runs strictly before networking, but if one of our services depend on networking, we have a full deadlock of the system. The system will actually hang at that point indefinitely because we can't resolve this dependency issue. And of course, deadlocking a system on boot just never ends in happy users. So let's ignore this issue for now. Okay, just pretend we didn't talk about that. This now begs the question, what about other services that start early in boot? Right? What if we want to configure them via CloudinIt? How early do we need to run CloudinIt in order to successfully start all of the services on our system? So it turns out there is no correct answer for this. We cannot know how early they need to start. And so we're instead forced to run it at some other point. So this is the current state of affairs with CloudinIt. We have serially starting services. We've got bash scripts that we're using to configure our system. This doesn't really sound like an operating system that's truly leveraging systemd as much as it could, right? So how do we fix this? Well, let's run through a few ideas I had here right before the show. What if we run CloudinIt after the networking? We configure the machine, we write files, create users, whatever we need to do, and then we reboot the machine, all right? Then on that next boot, the machine is already configured, right? This isn't a terrible approach. It has two drawbacks, though. That first boot is actually going to be 2 boots, right? We boot up the machine, we configure it. Once it's done, we reboot, and now we begin accepting work. So that slows down the initial process. The other problem is that if you're running these instances via cloud service like Azure, GCE, AWS, they'll see this machine come up after the first boot and say, we got it, we're good, your machine is up and running, and it may actually end up failing during this configuration state. So that's not ideal. Well, what about if we take CloudinIt and we instead run it before the machine begins booting? What if we run it from the initRD? At this point, we no longer have access to the user space systemd, so let's strip out the ability to start services. And for simplicity's sake, let's also strip out the ability for us to do any sort of variable expansion. This utility would effectively just be responsible for configuring disks. This is ignition, right? So at this point now, it's the same old systemd that we're using everywhere else around the world on our servers, right? You configure a machine, you write the services that you want to start, you enable certain services to run on boot, and you just hit the power button, and it comes up the same way every time. We want to leverage this with ignition. Now, given this timeline, we no longer actually care about when the network comes up, so let's just go ahead and remove it from our boot timeline for now. So we have ignition at this point writing files to disk. The question that remains to be answered, though, is how do we get dynamic configuration data into ignition, right? We're not going to spin up 1,000 identical machines with the same IP addresses and the exact same configuration. That's not useful. How do we actually get this metadata in place? Well, it turns out we can use a feature of systemd called environment variable expansion to inject at runtime any custom data we need into our services. If we have this, for example, CoreOS metadata target, any services which depend on this metadata just need to depend on the target. And they are, through systemd's mechanisms, guaranteed to be started after we have the metadata necessary to configure this machine. So at this point, we've got a very happy user. So let's talk about this metadata. This is the fact that we're substituting in metadata at runtime via this service really levels the playing field in terms of who can provide metadata to an instance. This means that CoreOS can give you a metadata agent. And when I say metadata agent, this is the utility that's going to go out to your specific source of truth on your network and pull back data. So on EC2, this will be the EC2 metadata service. On Azure, this will be the Azure Fabric. Similarly, for all of the different cloud providers available. Additionally, your cloud provider can actually provide you a small snippet, a small ignition config snippet, which will pull down all of the necessary bits to talk with their cloud service. So this opens the door for all sorts of mom and pop cloud providers to come out of the woodwork and have first-class support of CoreOS on their system. All they need to do is provide their users with the few-line snippet that's going to go out to the internet on first boot, grab the metadata agent that's necessary, and then tell that metadata agent to talk with whatever backend they're using, right? They could do something as crazy as using Bluetooth dongles connected to their servers, right? They ship in a container. The kernel module is necessary to talk with this Bluetooth thing, and they fire out over this Bluetooth network, and they pull everything in. They could contain that entirely within a container, and the user would be none the wiser, and it would be several lines of config. That's pretty nice. This also means that our appliance vendors can tack onto this ability and start providing first-class support of CoreOS on whatever appliance that they're working on. And finally, one of the most interesting cases is the user now has the ability to provide an authoritative metadata agent for the system. Of course, anyone who's running 10,000 servers in their data center, raise your hand if you have a data center. Ooh, a fair number of people, sick. you now have the ability to pixie boot all of these machines and provide whatever custom metadata service you need to get IP addresses, regions, hostname, anything that you need to get work done, you can provide via this metadata agent. So knowing all this, let's go back to our boot timeline real quick. And let's walk through an example here. So of course, the first major event is a power on event, shortly after which we're going to enter the init ramfs. Now, for those not familiar with the Linux boot process, the initial ramfs is the stage at which Linux is going to do whatever is necessary to talk with the root hard disk. Historically, this has been loading whatever kernel modules are needed for your particular SCSI disk or file systems or whatever it may be. But we're going to piggyback on this stage and run ignition from this point. So ignition, of course, is going to configure this disk at this point. It's going to write down service files. It's going to write down any other configuration you need on your system. And once it finishes, it's going to pivot into user space boot. So at this point, this is the moment that systemd takes over and begins starting our system. We already have all of the files necessary on the system. So in this particular example, let's say we're going to run etcd2. Okay? The first thing that, assuming you have your service files written correctly, the first thing that systemd is going to fire off is this example my cloud metadata service. Right? This is one of these agents that's going to go out to wherever and pull down some metadata, public addresses, private addresses. It's then going to write those into a known temporary location on disk. And once it completes that, we will have fulfilled the CoreOS metadata target. Of course, once we fulfill this, etcd2 is free to start. And etcd2 is going to source in that file that we just wrote. It's going to pull out the public and private addresses. It's going to insert them into its service, start, and once it's successfully started, we'll have fulfilled the multi-user target. So at this point now, we have a running system. It's been configured properly. We've got a happy user. Well, where does CloudinIt come into this picture? Right? What if I'm still using CloudinIt? I don't want my servers to upgrade into this new paradigm if it's just going to break everything that I have today. Well, as it turns out, CloudinIt will actually be smart enough to recognize that you're using an ignition config and ignore it. It'll be a no-op. This now gives you the ability to choose one or the other. You're going to use ignition to configure and boot, or you're going to use CloudinIt. You can't use both, but this will give you the ability to prevent yourself from shooting yourself in the foot too easily, frankly. So let's actually go through an example here and see how this works in practice. So I realize this text is small, so I'm going to read through this for you. This is an etcd2 service file, run-of-the-mill. I pulled it straight off of user lib, but I've made a few modifications to it. The first one that I want to point out is that I've added two clauses here, requires and after. And what this in effect is going to tell us is that in order to start etcd2, I need to have already fulfilled the CoreOS metadata target. Remember, this is the target that is responsible for writing our configuration data to this temporary location. The next change is we're going to be sourcing in this file. In this particular case, we're writing it to run metadata CoreOS. And then we're going to use this in our exec start line, and we're going to be substituting in the CoreOS IPv4 public address. So let's actually see this thing work. Demo time. Let's all take a quick moment to say a prayer to the demo gods while I set this up. All right, and here we go. We're all set up. So the one piece of data that I'm going to be giving to this machine is this small clause. And this is going to be passed into the kernel config. And all this is telling us is that you can find the config URL at this address and it is this etcd JSON blob. I have a local web server running, which is going to serve this up. I don't trust the conference network here quite that much. And I have a QEMU instance, which is we're actually going to demo here. So let me make sure I have this in my, oops, where are we? Make sure I have this in my paste buffer. Okay. And we're actually going to fire off our instance here. Now, I know that was quick there, so I'll just walk you through what I did. We were at the grub boot prompt, and I just asked it to edit this one line for me. So we're going to inject that same line, write it to the end of our boot parameters, and we're going to kick off the boot. Are you guys ready? It's going to go fast. Here we go. So we've begun booting. It's going to grab an IP address from a locally running DHCP server. You can see it's starting ignition. Sick. All right, that's good. It's booting, and that's it. We're up and running. So let's see if it actually worked. Remember, we were trying to configure etcd2. If all goes well, etcd2 will have started. And I also have to get the command right. Boom. So it's running. Yeah, we did it. Yes, we got it. All right, he's just pulling the wool over our eyes here. He already put the IP addresses in there. We all know this trick. All right. So if we look, I don't want to use the pointer, so you're going to have to follow me. So we can see the advertised client URLs has an IP address in line. So it is actually using an IP address. But let's see where that comes from. Whoops. So if we cat out the etcd2 service file, we'll see that I haven't hard-coded the IP address here. We're actually using this environment variable substitution. And you'll notice a few lines above, you can see the environment file being sourced in. This is run metadata CoreOS. So let's see what's actually in this file. Well, as one might expect, it's the public address. The metadata target provided this file to us. We sourced it in, and we used it to start etcd. Now, for demonstration purposes, I drastically slowed down the network to make this a bit more obvious. But let's take a look at the boot time on this. So in this particular case, we took 13.5 seconds to boot. Now, because ignition only needs to run before the first boot, theoretically, the next boot should be significantly faster, right? Let's see. So do me a favor and remember 13.5 seconds. And we're going to reboot this box. Booting through the initRD, we're stepping into user space boot. It's kicking off all of our services. It seemed a little faster. Let's just double check that etcd2 actually started. It's running again. It's using that IP address. Actually, it's a different IP address you can see this time. So it is, in fact, dynamic. Last time was .50. This time we got .51. And if we check the amount of time it took to boot, we're now down to 5.5 seconds. So it worked. So ignition came up before that first boot. It configured our machine in the way that we needed it to. And it got out of the way. It never runs again at this point. And so our system boots extremely quickly, and it's doing the bare minimum it needs to get your system into the running state. So what's next? When can we use this? Ignition is still under very active development. We're a few months away from shipping this in CoreOS. So you can follow along on GitHub. It's github.com/CoreOS/ignition. This utility, as I said, will supersede CloudinIt, but it will not break your existing machines. When we update your machine, if you're using CloudinIt, it will continue to use CloudinIt the same way that it always has. But you now have the opportunity to use ignition in your machine. And I'm telling you all this not to tease you and, hey, look what we're working on. It is to get you guys thinking about how can I utilize this? How can I take advantage of this new boot process, this simpler boot process? What can I do to make my life easier in the next few months once this is available? That's all I had. Thank you very much, everyone.
So we do have time for, I think, 1 or 2 questions as Brad gets set up here.
OK. Any questions? No questions? Ooh.
It was too awesome, Alec.
I can't tell if that's good or bad. Did I answer all the questions?
It was too awesome.
OK.
Too awesome.
Hi.
OK. Oh,
so,
we got one.
So what would be the workflow if I were to ship an appliance and it has ignition and the metadata service, where the customer would want to be able to configure the IP address on first boot?
So for appliance vendors, what you can do is actually include a small snippet. And that snippet would do whatever's necessary to configure that particular piece of equipment. So let's say your equipment has 10 Ethernet jacks on it. That could go through and set up each and every one of them and then provide the metadata service. And the metadata service may be as simple as just a shell script that figures out the addresses on them. But it would allow you to customize it for that particular piece of hardware. Does that make sense? Did I answer your question?
Kind of. So how would the customer be able to overwrite the IP? So say we ship an appliance with 10.0.0.1 as and one interface, right? How would the customer be able to overwrite the IP address used in subsequent boots?
So if ignition is writing the static config at runtime and it knows the address, then the user could just go into etc systemd and start tweaking that. They're free to change those files. The ignition isn't going to step on their toes after the fact. But if you are going to be leveraging dynamic data, then I would encourage you to use a dynamic service during boot to figure out those addresses and configure them properly. And we can talk more afterward. I can talk everyone's ear off if they want afterward. I think they're kicking me off stage here. Are there any last questions? A short one, maybe? No?
You're
All right.
good.
Perfect. Thank you.